Welcome back, participants. Today, the ninth session is also handled by Mr. Ramaguru Radhakrishanan, and the application, whichever the application has been stopped in the morning session, it will be continued by Ramaguru Radhakrishanan. And sir, the session is handled to you, and you can take the session.
So, good afternoon, everyone. So, hope you are able to see my screen. Yeah. So, one input, maybe during the previous session, it was all told in words, right? Because one challenge in blockchain application is that even if you go to any demo applications, you'll not be able to get a complete idea. Each application will only give an idea of certain things, which is part of the application. You should correlate and understand. So that's how it is, because most of the thing as such, it is distributed. It is not, if it is hosted by single server, you will be able to host it in your system and you will be able to understand. But since this is a distributed thing, to actually imagine how it would work itself is a very difficult thing. So that is one of the challenge a lot of the new learners or beginners who learn blockchain face. So maybe during the morning session, you might have only felt, I told a lot of applications and I explained only in theory. Maybe some of you thought I could have gone to maybe that medical chain and showed some transaction. Such things are not possible because most of those applications are paid. There is no demo. And even if there is a demo, then you have to install a lot of other things in your application, in your system, to even try that. So such challenges do exist. Okay. So, so one of the application I'll try to create using Ethereum blockchain. And whatever we are going to do now, you may not understand it fully. And here the intention is not just to teach you and make you understand everything, because that is totally not possible, because whatever I am going to do now is what normally we teach for an MTech blockchain 4 or 5 credit course over a 30-40 hour. Okay, so whatever I am going to teach, whatever I am going to show, it requires a very good effort in understanding so many things. So within 1.5 hours, you'll not be able to understand, but you can know the different terms. You can know how it is working together. Then maybe if you're later interested, you can go deep into each of those things. Okay, so here the intention is to practically show. I am going to just create something and show you this is how it is going to work. Okay, and some demo. So you will be able to understand, okay, this is how it is all talking, such things you will be able to understand. You may not create an application at the end of this session. That is not the intention, and that is practically not at all possible within a 1.5 hour session. Okay. So with that note, let us see. Building compelling blockchain applications using Ethereum blockchain. If you remember yesterday, I told Ethereum belongs to the second generation of blockchain, where above the cryptocurrency logic, a user will be able to create their own applications, right? This was one thing we saw. One. Next is Ethereum, since being a public and an open blockchain, this is one of the widely used blockchain. You take any blockchain application that is existing today, most of the applications will be running on Ethereum or Ethereum-like blockchain. So some people even refer the Ethereum blockchain as world computer. Okay, and Ethereum blockchain was started, the Genesis block was mined in 2015. So it is only 5 years old compared to Bitcoin, which is almost 11 years old. Okay. So yes, Ethereum has all other things, like it is again a blockchain. It is again going to use proof of work, but it is using memory-based proof of work. Okay. And the other important thing that actually made Ethereum so big is smart contract. The user will be able to create a smart contract, and that smart contract can be executed on a blockchain. So this particular feature or this particular technology allowed people to create their own logic and deploy it on top of a blockchain, which is actually, this particular contract will actually reside in all the nodes of the blockchain. And all the nodes will execute these transactions. Okay. And this application runs not on one system, but on all the nodes of the blockchain. So smart contract, if I have to define it, it is nothing but a self-executing computer or a digital program or an agreement between two or more parties. Till this is simple. That is even available today, right? You take a bank standing instruction, which you would have given, right? Every month, 5th, from my account, my savings bank account, this much amount has been transacted to my loan account, right? That is self-executing, right? Every month, 5th, it is getting executed, right? And that is again a computer or a digital contract, right? And that is agreed between two parties. One is you, and you would have given the standing instruction to the bank. Or in case every month, 5th, this much amount has been transferred from my account to my house owner account, then it is the contract between you and your house owner, and every month 50th is getting executed. So till this, from self-executing computer or digital agreement between two or more parties is even existing for a long time, right? But that is getting executed on a standalone centralized system. But if you take this smart contract, this is getting executed on a distributed and a decentralized system like blockchain. So that is something new, which was not achievable until smart contract actually came in Bitcoin. But if you look at smart contract, is it something new? No. Smart contract is something that was defined by a person called Nick Szabo in 1997-1990. During that time itself, he has published an idea of how a digital contract should actually work between multiple party, which completely eliminates an intervention of a third party or a intermediary during a transaction. So this is one big contribution from Ethereum blockchain. Okay, so what is that we are going to do is we will write a smart contract if you want to create a application. So you will write the smart contract, and this smart contract is going to be the application logic, or if it is going to be a business application, this smart contract will contain all the business logics of your application. And this smart contract enables the communication between the outside world and the underlying blockchain. So this smart contract is going to help you to talk to blockchain from maybe the front end or any other third party application. So this is something that is in between. Okay, so this is what you write on top of blockchain to create a application. Okay, so before that, let us quickly understand where exactly we are and what all things could change and what all things could be same. Okay, so let us take the traditional application, right? You will have a front end page that is typically developed using HTML, CSS, and JavaScript, right? This particular front end page, how do you get? You go to www.example.com, then it will access 80, right? HTTP, it will go to 80. If it is HTTPS, port number 443 is contacted, right? Or if you are running any customized service, it will be in a defined port, right? You Google, you give this address, automatically there are different protocols that comes into picture, right? Your address resolution protocol, domain naming service, all those comes and resolves this example.com to an IP address, and this IP address is again found a particular server. From there, this particular file is served, which is viewed in your browser. And if there are some values that you are trying to store or access, then you will have a database name, you will have a table name, you will have a query, and that query goes across. And from the database, the values are fetched and displayed on your browser, or either from the browser, the values are stored into the database. So this is what, on a very high level, if you see, that happens in a communication in the centralized system, right? Now, if you take a decentralized system, maybe your web contents are still in the centralized server, maybe. Okay. So whenever you give that example.com, again, the same thing, and the web page is served. But here, instead of the database, what you are doing, you are storing all your data in a blockchain. To facilitate that communication, you are using a smart contract. So you write a smart contract, just like how a querying language helps you to talk to the database that is storing your data. Here, the smart contract is going to help you to talk to the blockchain, which is going to store your data. And this Ethereum blockchain is not one centralized server like this, but it is going to be a distributed system across many countries, across many continents. Hundreds and thousands of systems could hold your data. Okay. One. Now, so you got this on a very simple level, you can understand, like, it is replacing the database. Instead of storing it in a database, you store it in the blockchain, and you get all the advantages of the blockchain. Okay. And just like how the querying language is helping you to talk to the database, here, the smart contract is going to help you to talk to the blockchain. Also, it is going to define the core application or business logic. This is one thing. Next. So the first thing, whenever you want to create an application on top of a blockchain, the first thing that you have to write is a smart contract, which can be written in any high-level programming language like Java, Python, Go. But Ethereum people have created a specific language for writing smart contract, which is called Solidity. They call it Solidity programming language. Okay. So this is first thing that you should know if you want to create a distributed application on top of blockchain. Okay. This. Next is, this is a secondary tool only. To write this programming language, you need a compiler of Solidity. You need an environment where you can write all those things. So that there is an online tool which is already defined with everything, so that without even to install something on your computer, you can use this Remix IDE. Okay. Now next, since this is completely part of the centralized system, okay, when you tell example.com, there is a particular service which will tell you, okay, this is the IP address of the example.com. So your computer knows, your browser knows which IP address to contact. Okay. But here, your smart contract or your code is there in all the systems of the blockchain. So this example.com will help you get the front-end UI. But how do you connect to the database? Which IP address you will use? So that you don't know. So here, to contact the smart contract, you get something called as smart contract address. Just like how to contact this database, you should know the IP address, the database name, the table name. Here, to contact the smart contract, you should know the smart contract address. One. Here, just like how you have a API, application programming interface, to talk to the smart contract, you need something called as ABI, which is similar to your querying language. You have select star from, right? So similarly, here there is an ABI which tells how to talk to the smart contract. So these are the two things that is needed to talk to the blockchain from the present day system. if you want to talk to a decentralized network, these are the two things that you need in Ethereum. And to support the programming, apart from the normal JavaScript, you need the additional JavaScript called Web3.js. So Web3.js is a JavaScript module or a library that helps you to create the front-end logic that will help you to talk to the blockchain. And to talk to the blockchain, like whenever I say blockchain, it is via the smart contract to the blockchain. You need two things. One is the smart contract address, another is application binary interface. Okay. And now, as I told, there are some services that will tell you this, if this is the domain name, this is the IP address. So similarly, if this is the smart contract address, how to identify and connect and how to talk to, you need some bridge. So there is a bridge or a software that you have to install, which is called MetaMask. This is a browser extension that you have to install. So this will act as a bridge from your centralized internet to talk to that smart contract that is existing on the blockchain. This MetaMask will act as a bridge, communication bridge. That is one thing. Additionally, MetaMask is also a wallet, which will store your cryptocurrency. Okay, so these are the requirements. Okay, so now let us see from the middle, not from the first or not from the last, from the middle, because the bridge is more important. You already have your browser, right? This browser enables communication from your browser to any centralized internet or from your browser to any decentralized internet also, right? So first you have to install the bridge. So this is MetaMask, okay, which helps you to connect to either mainnet or testnet. You remember mainnet is something where it has a value, okay, it has some real-time value. Can you see 0 ethers? I don't own any ethers. I have 0 ethers. Since this is Ethereum blockchain, the cryptocurrency is called ether. And since I have 0 ethers, the unit conversion to United States dollar is 0, where everything is real. But whereas testnet, it is dummy, just for understanding the blockchain, to test deploy and understand how it works. So there I have 5.2 ethers, but this is test ethers. You cannot exchange it or something. Okay. So now this is the wallet. This wallet helps you to, as I told, helps you to store the private and public key, and it will display your balance, which is taken from the blockchain. So this is the MetaMask, which acts both as a wallet and as a bridge between your browser to the decentralized internet. In this case, it is the Ethereum blockchain. So whatever I do from the front end, it will be directed via this MetaMask, and MetaMask will send it to the smart contract, and smart contract will talk to the underlying blockchain. So this is how the communication goes. So now if I come here, this is a sample application. Okay, so whatever I do here, okay, let us go here. I'm just going to I have already stored a lot of certificates here, so I'm just going to retrieve one certificate and show it to you. 2020060101. If this is going to be some unique ID, can you see I have retrieved a value from the blockchain. So now when I enter this ID and click view certificate, let us understand first how the communication happens. When I click here, just like how you need an IP address and port number to communicate in a centralized internet, here you need the smart contract address and the application binary interface. So that is available in this front end, which is written using the tool I told, Web3.js. Okay. So if you look at it, you will see the smart contract address. So this is the address that has the logic of how I create a certificate and store it in blockchain, and how I retrieve the certificate and show it in the front end. That particular logic is returned, and after deploying it, I will get this unique address. So now this page is using that address and the ABI with this particular value, and it is talking to MetaMask. What this MetaMask will do is it will take this request and send it to the decentralized internet, because MetaMask know how to find the system for this particular contract address. Now it goes to the blockchain network, fetches the data, redirects it back to the MetaMask, and MetaMask gives it back to the front end. So this is the communication channel. So that is the job of MetaMask. If this MetaMask is not there, even if I give you this link, you will not be able to retrieve this data, because the bridge is missing, which will break the connection between your browser and the blockchain ecosystem. One. So how do I install this? This is very simple. You just need to follow the instructions given here. You just need to enable this extension and click next, next, next. It will ask you to do few things. You have to do that. Okay. So I'm just sharing this link. You can do it at a later time. Okay. So this is one thing. So once you install the MetaMask, it will be having 0 ethers. You will not have any money in your ether. So just like how I showed yesterday, there is something called as faucet for Ethereum also. You can go and request money from the faucet. Okay. So you go to the faucet and you request money. Once if you use this link, if you click request 1 ether from the faucet, you will get 1 ether into your account. So balance, after installing MetaMask, what you have to do is you have to go to this particular link. All these links are given in my presentations. So once I share the presentation, you can try them. I'm also sharing it in the chat for someone who is already aware of all these things, they can try. Okay. So once you request 1 ether from here, you will get the balance updated to 1 ether. And sometimes you will get error messages because there is a limit that you cannot get more ethers. Okay. So if you are requesting 1 ether, now you cannot request it immediately after some time. It will take a lot of time. But with 1 ether, you will be able to do lot of transactions. Now, one other thing you might have a doubt now is why I do need ethers. As I told yesterday, the transactions that you send are stored in other people's computer, other people node, and they are doing some computation effort to process your transaction. So to pay them for the work they do, you pay in ether, and they can go to exchange and exchange it to their own currency. So that is how you incentivize them for the work they do. Okay. So is that clear? Why is this MetaMask needed? And this is a very simple installation only. I think you can do it in 5-10 minutes. So this is one thing. Okay. Is that clear? So now next we have another 1 hour. So I would like to explain 2 other things taking half an hour each for them. Okay, next is again teaching Solidity. It's, you know, I cannot teach one programming language during this half an hour session, but for a quick introduction and quick examples I can show. So this is the remix environment that I told. So this is just the link, remix.ethereum.org. So you go to this, you will you can start writing your program here, and once you go, you have to select the plugin that is you are going to use, the Solidity programming language. So you select this, and you can close the home button here within the main area. You will see close. Okay. So if you want that home screen back, you can click this link. And this is the file explorer area. By default, there will be 3 example programs that is available. One is one underscore storage.sol. Next is 2 underscore owner.sol. Next is 3 underscore ballot.sol. So these are the 3 simple examples by default you will have in the file explorer area. If you want to create your own file, you just need to click this plus button and you can write, okay, ATAL, I'm just going to create ATAL FTP. You can use any naming convention that you think is suitable for you. But like any other programming language, the Solidity programming language ends with an extension .sol. Like C is .c, C++ is .cpp, like Java is .java. Solidity programming language ends with an extension .sol. Okay. Now, a quick note on what is the structure of a Solidity program and how it is similar to what. Okay. The first line of any Solidity programming language is pragma, solidity, and a version. So you remember C, the first line normally we write initially was hash include stdio.h, right? Hash include conio.h. The header files will come. Similarly, you look at Java. If you want to import, you will have import java.io.star, something like that. So here for Solidity, you tell what is the compiler version that is used to compile this program. So you say pragma, solidity, and you can either tell one version like this. You can just tell it should be greater than or equal to 7. Or you can tell a range. It should be between 7 and 8. Okay. So this is for you to know, and how to select that version depends on what are the features you are using, right? So this is one thing. Next, Solidity programming language is an object-based language which is similar to Java or your C++. So if you remember Java, you will have a class, right? And a class name, right? And within the class, you will have some variables, right? Int a, or let us say int roll number, right? String name, you will have some variables like this, and something like some functions you will have, right? Void, get name, and you will get those parameters, right? Similarly, you will have void, set name, or get name and set name if you mean it is same, return names. You can keep anything. So this is how normally you write a Java class, right? There is a class, and within the class you have variables and functions that operate on those variables, right? And whenever you want to access this class, you create a object, right? Here it is again the same way. But here the class is going to represent only one thing. What? It is going to represent a contract. So instead of the keyword class, we have the keyword called contract. Okay. So you say contract storage, which means now this storage is a smart contract. And within that smart contract, you can write whatever you want. One. In normal class, you call these things as variables. But here, in a smart contract, whatever variable you declare, those variables are automatically stored in a blockchain. Even if you declare, declare the variable itself, this variable will be stored in the blockchain with the value as 0. Now, if I deploy this into blockchain, roll number will be stored onto the blockchain with the value 0. Name will be stored onto the blockchain with the value null. So these variables are called state variables because these variables represent a state in the contract. Okay. So this is one change. Instead of class, it is contract. Now, similarly, the flow is same, but only the structure or the way in which you define is different. Here, as I told, since the storage is done by some other person, for the how much amount of data you store, or how big the transaction size, that much transaction fee you have to pay. So each bit or each byte that you use in a contract is going to cost you some transaction fee. So you have to use it very cautiously. So instead of just int, what they have told is you have to define specifically how much is that. It is whether this int is going to store 8 bits or 16 bits or 256 bits. You have to define like that. Or if it is an unsigned int, then you have to say u into 256. So now it is clearly defined that this variable maximum can store 256 bits. Or you can clearly tell it can store 128 bits. So such differences are there. But otherwise the meaning is same. It is again an integer variable. Okay. Similarly for functions also, the way is different. You tell that it is a function by adding a keyword called function. Okay. And you can give any variable name. And the return type normally you give at the front. Here it is at the last. That's all. And just like how you get the variables from the function, here you can get. Okay. Now, what is that when you assign this? When you do this, no, what happens is the value that comes from the user from the front end is now assigned to this roll number, which is the state variable. Now it will be stored in the blockchain. Now this variable that is again coming from the front end or the user will be stored into name, which is stored into the blockchain. Okay. But again, as I told, storage here is going to be costly because whatever you store is stored in all the computers of the blockchain network. So for each, even if it is 1 bit or 1 byte, you have to be very responsible because that is going to cost you a transaction fee. And that transaction fee, whenever you do a transaction, you have to pay from your ether, right? So you have to be very cautious about what you do. So for that sake, these are the variables that are temporary variables, right? Local variables, which is needed only until the values are assigned to the main state variables. So these should be explicitly told that these are temporary variables. Okay. So it should not be stored onto the blockchain. It should be only kept it in the execution memory. So we have to add a keyword called memory, which will make this variable store it in the memory, but not store it in the blockchain, with one exception. For integer, you need not tell that because if it is in a local variable state, automatically it identifies and it puts into the memory. But for other data type other than integer, you have to explicitly add the keyword memory just before the variable name so that this particular variable value is not stored in the blockchain but kept it in the memory. Okay. And returning is again simple. Similarly, function can give any variable name. Similarly, return type is this. Now, if you give public, other person can access this function. But if they want to view the values, you have to add an additional identifier called or modifier called view. So people can, any external code can access this function, and if it is returning something, they can also view this. And you have to explicitly tell what is that it is returning. So what is that we are going to return? We are going to return the roll number and the name, because those are the two state variables, right? These are the two state variables. We got the value and we have stored. Now we are going to return that. Normally in other programming languages, we will have only return statement within the function. Here, we tell the return statement here, and also here, just by mentioning the data type. Now you tell this, these two values are returned. Roll number is of this data type, name is of string data type that has to be stored in the memory. Okay. Now, since storage is itself a keyword, we can keep storage example I'll put. Okay. Now, this is your first smart contract code. That's all. Now, if you are good in programming languages like Java, what you can do? You can create a structure and you can add as many functions as you want, and you can add as many variables as you want. For example, if you want I int 128, you tell mark 1, u int 228 mark 2, u int mark 3. Okay. And again, you do this and say total. Okay. What you can do? You can get all those variables from the user again. M1, M2, M3. You can get all these things and you can do your own calculations here. Assign mark 1 from M1, assign mark 2 to M2, assign mark 3 to M3. Okay. And total, you know how to calculate. Total is equal to mark 1 plus mark 2 also you can give, or M1 plus M2 plus M3 also you can give. That's all. Now, all other values you received from the user and you directly assigned it to the state variables. Total you used the existing value to calculate. And if you want to return here, you just need to say here mark 1, mark 2 and mark 3, and correspondingly add the return types here. This is a simple contract. Now you can elaborate it as big as you want. You can add additional functions, or what you can do. What are the other things if you are a good programmer, if you know programming, you can do all other things. The only change here is instead of contract, instead of class, it is contract, because it is only the contract it is representing, one. And the way in which you declare the data type is different, and way in which you declare the function is different. But otherwise, it is similar to any other programming operating object-oriented programming languages you know. It works like that. So that's all. So this is how you write a programming in a Solidity. This is now a smart contract, right? This is a very simple smart contract that will store a student's mark detail and return those details from the blockchain. That's all. A simple contract which will get a student, only one student detail, and store it in the blockchain and return that student detail. If you want to store it for multiple students, then you have to make this as an array. That's all. And like any other programming language, every statement ends with a semicolon. Okay. So this is what if you take a good considerable effort, you can learn Solidity very easily if you are already good in programming, or if you're already aware of any object-oriented programming language. So now, is this clear? The structure of a Solidity programming language, what all things it will contain. The first line is Pragma Solidity, the structure of a contract, what are state variables, and how a function is returned. Just a keyword called function is added at front, then the function name, if there are any parameters, then finally the visibility of the function, and if it is returning something, you should add a keyword called view. These are some of the differences. And since this is costly for storage, except integer, if it is any other data type, for the local variables, you should mention the keyword memory in addition to that, indicating that this is now stored in the memory, not in the blockchain. So storing in the blockchain is very simple. You declare it within the contract. Those variables are state variables, and all the state variables are stored in the blockchain. So is that clear? A couple of responses. Is it clear? Any doubts? Okay, wonderful. So now, So this is the first part, okay, the file explorer part, okay. Now the next part is the compiler section, okay. So as you need not worry much about this during your initial stage. If you give this pragma solidity, automatically the version will automatically be set. But just for information sake, I'm telling it will contain all the versions that is published in the solidity GitHub. Okay. So automatically based on what you give in your first line of the code, automatically the version will be selected. One. Next. The language, since you are writing in Solidity, you select Solidity. Don't worry too much about that. Now, third is EVM version. So, EVM is nothing but Ethereum Virtual Machine. Okay. Ethereum Virtual Machine is nothing but very much similar to JVM, Java Virtual Machine. You know, right? Whenever you write a Java program, the Java program is converted into bytecode. That is making it platform independent, right? The bytecode then, based on what kind of operating system and hardware, this thing, it is then getting converted accordingly, and that is getting executed. That is why it is getting executed in the JVM, right? Java Virtual Machine. So here, again, the blockchain could be running in any system of any architecture with any hardwares, right? So to make it actually run on all these systems, all the transactions that we do, all the smart contract executions that we do are getting executed in a virtual sandbox environment called Ethereum Virtual Machine. So these are the different versions of Ethereum itself. So just without giving a number, they are using a keyword. So these are the different keywords, okay, different versions. Just like how in Android, right, we call it Android, Oreo, Lollipop, such things, right? So here it is called by different name. The current version of Ethereum is Muir Glaciers, which is not available here, I think. The current version that we are using in Ethereum is Muir Glacier, okay. And you can select auto compile so that it is automatically, whenever you do this, whenever you do any changes, like you press a space, it will automatically compile. You need not even come to this UI. You can write a program automatically. You can skip this if you give auto compile. So whenever you do some changes, it is automatically compiled. And if there is some error, you will be able to see below. And once it is compiled, you will get two outputs. One is the bytecode, okay, which is there. You need not worry about it, but just for information, I am telling. Then next is the ABI. This ABI is needed when you are creating a front end. Okay. So this ABI is needed if you are creating a front end. Now, the next is the deploy and run transaction. If you look at other programming languages, you can run. Once you compile, immediately you can run the program. Once, if it is working, then only what you will do, you will deploy. For example, you create a mobile app, you can see how the application will look in the emulator itself. If it is good, then you can create a package.apk and you can send it to your mobile and install. But here, since this is blockchain, you have to actually first deploy it somewhere. Then only you can run. That's why it is deploy and run transaction. You have to deploy the application first. Only then you can run. Okay. And to make things simple during an initial stage, what you can do is you can run it in JavaScript virtual machine, which is JVM, which means it will run in your browser itself. It will assume that your browser itself has a blockchain and it will execute it here. If you want to talk to an actual blockchain, then you can select injected Web3. Now it will talk to whatever you send will go via MetaMask. So now I can show that. Can you see here? My account number is P6FE. Okay. And my balance is 5.2323. Okay. Now when I selected injected Web3, automatically you see my account number C6F. Can you see? 5.2323. And you can see only one account because now this is connected to my MetaMask. So whatever I do will go via MetaMask. So I can talk to the actual blockchain. But if I want to quickly, without wasting any transaction fee, without wasting any network delay, if I want to quickly check whether it is working or not, I can select JavaScript VM, which will run within my browser itself. And here you see you have 100 ethers and you have so many accounts. So you can select any account and you can do the transaction. So now I have selected one account. I'm just going to click deploy. And you see here, this is the console, the bottom area, what you see is the console. And once I deployed, you can see here. You will see here, and it is showing memory. Can you see here memory? Which means now this particular contract that was deployed is running in the browser's memory. It is not in the blockchain. So that you can see here. One other indication here. Can you see here VM? Which means this transaction now, which got executed successfully, is in the virtual machine, not on the real blockchain. Okay. So now this is the quick UI. If you want to quickly test, it will give you a sample UI without you spending and creating time on your own. The ID itself will give a quick UI. So what you can do, you can give those informations. I can give 1, 2, roll number. Okay. Ramaguru R. Subject 1 mark 87. Subject 2 mark 78. Subject 3 mark 90. Okay. Now, one other thing you have to notice, can you see here? The balance was 100 ether. Now it is 99.99999 so 816 ether. Why? Because as I told, whenever you do something, you have to pay a transaction fee. So when you deployed the contract, what happened? The contract was deployed in what form? In bytecode. So the bytecode is now sent as a transaction to all the nodes in the Ethereum network. They would have received it and they would have stored it in their system. For that you have to pay, right? So that transaction fee was deducted. And 1 ether is divided into 10 to the power of 18. If you remember yesterday, 1 Bitcoin was 10 to the power of 8 Satoshis. Here 1 ether is 10 to the power of 18. That is why you see more decimal points here. Okay. Now you can see the value. It is ending with 816. Okay. Now I'm going to do this transaction. What? I'm going to store, which is again going to take some storage space. So again, I need to pay some transaction fee. Okay. Now it is stored. Now let us go back and see. Can you see now? Previously it was some 816, 452, 816. Now it is 451, 757. Why? Because I have stored 5 integer values, which is of 128 bits and 1 string value. So accordingly, my transaction fee would have got detected. Okay. Now I'm going to call the return function. So when I click return, you will be able to see the values are returned from the blockchain. 12, Ramaguru R, 87, 78, 90. So this is how you create a distributed application on top of blockchain. Now this application, now instead of deploying it in JavaScript VM, if you deploy it in the blockchain, what will happen? It will get deployed into the blockchain, which will form your backend, right? Which will form the backend, this one. Now, what is the next task? Your MetaMask is already there. Your smart contract is already there. Now you need to copy the smart contract address and the ABI and create a front end and establish the communication. If you do that, you have a distributed application or a decentralized application that is ready. Now, let us modify this application result. Now you already saw, right? You already saw when I gave this deploy, it got deployed, right? Now, quickly 1 minute. This particular code, I'll mail it to you, or I'll. These things are already available in my GitHub repositories. Okay, so I can give you that link, so you can. There are more examples which is written in a very simple way. Everything is explained very clearly, so you can just check on this Ethereum blog where I've explained all simple things in very, I think, as simple as I can. I have written. Okay, what is the solidity language? Okay, and what is the structure of the code? Okay, contract name, how to declare different variables and what it means, how to declare a structure, how a constructor is created, how a function should be created. Okay, all such things I have explained, the structure, and why a MetaMask and a faucet is needed. Okay, and other things also I have explained, and you'll be able to see the examples here. If you click those things, you'll be able to access the codes of the example. So I'll share this link. This will have all the examples that is needed. Okay. So do you have any doubts in this, like on these three things? These are the three things that are important: the file explorer area, the solidity compiler area, the third area is the deploying area. Any doubts in that? Sure, sir. I'll send the link in the PPT. I have updated the link in the PPT. So when I give that link, you'll be able to do, or in case if you need it now itself, yes, you can share also. Okay. So now, so is that okay? Is that back end part clear? Now, if that is clear, I would like to quickly touch upon the front end thing. Okay, what is this Web3.js? Okay, so Web3.js is nothing but a JavaScript library that enables communication. As I told, it will, from the front end, it will enable the communication to the remote Ethereum node using HTTP or remote procedural communication. Okay, so this particular code, you have to add it into your front end, and this is going to be the JavaScript type code. Okay, so the library or the main libraries of JavaScript, that Web3 JavaScript is available in this content delivery network. You can keep this like an import function. Okay, or if you are using it from your local machine, you can use an npm install. Okay, it is available as a Node.js package as well. You can install that. Okay, now let me say, so this is going to be the library that I need, which contains all the functions. So I have imported that. Next, what I'm doing is, now I know I am using a normal browser, right? A centralized browser. So the first thing, when I open my application, what is the first thing I should check? Whether this browser has a MetaMask, right? If this browser is not having a MetaMask, then the bridge is not there. Then I cannot talk to Ethereum blockchain. So the first thing what we do in a DApp is we check whether MetaMask is available or not. If MetaMask is not available, we will tell MetaMask is not available. Then the user knows that this application cannot work in my browser. So how do we check whether MetaMask is available or not? If MetaMask is available, then this particular variable is defined in the browser. So just quickly, because that is something to do with browser analysis, so I will not take much time on that. So now if you go here to any website and go to inspect, go to Google, any website, go to inspect and go to console. Okay, here if you type window.ethereum, you will get something like this. Okay, you type window.ethereum, window.ethereum. chain something. You type window.ethereum, automatically it will show you something. You can see something here. But you do the same thing in your browser, you will not get anything. It will show undefined. So if you have installed MetaMask in your browser, then all these variables are injected into the browser. All these variables of the Ethereum blockchain are injected into this browser. Then it means this MetaMask is available. That is why we call this as injected Web3. Your browser by default does not support Web3 functionalities, but it was injected by a extension. So that is why we call this injected Web3. Okay. So what we do is we check whether this particular window.ethereum is defined. If it is undefined, then MetaMask is not available. If it is not equal to undefined, then MetaMask is available. Okay. So we are doing such checking. Okay, we will check whether this is available or not. So we are doing certain check. Okay, not more on this, but so this is one code. This one section of code should by default be available in your source code. So you see my certificate issuer code. You see my this thing is there. The typical HTML page contents are there. Then this is the HTML code where I have created the table. This is the form, right? Which is nothing but this form: name, designation, institution, certificate ID, holder wallet address. So this is the HTML corresponding HTML code. So similarly, the remaining HTML code for this is available here. Okay. Below that you see immediately I would have started this import of the Web3 Java function. Then I am checking whether Java that Ethereum variables are defined or not. Okay. Now, this is one thing that you have to do. Next thing what I told, MetaMask should know which contract it has to talk to, right? And how it should talk to. So for that, there are two things that is needed. One is the smart contract address and another is the ABI. So whenever you compile a program, you will get a ABI. Whenever you deploy, okay, whenever you deploy a program, deploy a contract, you will get the address. So this is this address. You can click here, copy, it will come. So this address is nothing but the smart contract address, which you can copy from here. So whenever you compile, you get the application binary interface, which tells how to talk to. When you deploy, it creates a smart contract address, which will tell whom to talk to. Okay. So you have to copy these two things. Whenever you compile, you copy this. And you can store it in a notepad. Okay. And the ABI will be, oh, it is binary, it will not be in binary form, it will be in understandable form only. So it will just tell, it will be a JSON type file, which will tell some information. Okay, so this is the ABI of the code what we wrote now. Okay, and when you deploy it, you will get a contract address. So what do? You paste it here. Whatever ABI code you get, you paste it here. The ABI code based on your program, it will be as big as possible. Since I have written a very big contract, this is my ABI, which is almost 300 to 400 lines ABI, 500 lines. Okay. Then you tell the smart contract. So now, for example, if I give you this particular code, right, you need not change anything. What you have to change? You just need to change your front-end HTML. In the Web3 part, the only thing that you have to change is this. After this equal to ABI, you have to delete my ABI and copy your ABI. And instead of my smart contract address, you have to give your smart contract address, what you got when you deployed. Just to change those two variable names. That's all. Okay. Now, how do you contact the function that is there in the remix ID? Okay. So now these are the 2 lines that is needed. Okay. You have to say, just like as I told, in your Java programming, you will create the object wherever you want to access. So now I'm going to create an object. That is why new. And I'm going to use Web3 module. In this Web3, I'm going to contact Ethereum. In Ethereum, I'm going to use the contract related function. So that is why you are saying new web3.eth.contract. So now you told. Now you are telling, you should tell, right? I am trying to contact this particular contract address and which is having this particular ABI. So use this particular contract address and talk to that using this ABI. So that is what you are telling it here. Once you tell that, the object of that particular contract will be assigned to this particular variable. Got it? Normally, when you create an object, how do you create? You say class name, object name is equal to new class name, right? So similarly here, the object name is here. Here you can declare variable, and instead of giving the class, the contract name, you are giving the contract address. That's all. Normally you give new, the class name, you will call the constructor, right? Here you are calling the contract and you are telling this is the ABI. And you are telling which account I should use for detecting the fees. If I am storing, which is the account that I should use. So I am using my default account. So that is why I declared with the variable account. And once this is available, what you should do? You have to tell my contract dot methods dot functions. Okay. So now one minute. Okay. So now you have to say my contracts dot methods dot whichever function name you want to call, you have to use that function name. So in our case here, if you want to call get variable, what is that you have to use? You have to use here get variable name. So similarly here I want to use issue certificate, and I will pass all the variables that I got it from the front end. So now here it is there. So now what will I do? Whenever I enter this, so let us now take, I'm going to issue certificate to Karpagam University for attending this webinar. Okay. So I'm going to say Karpagam College of Engineering. Okay. Designation Department of CSC. Institution again Karpagam College of Engineering, Coimbatore. Certificate ID 2020-12-01. Okay. This is, I'm going to issue a certificate and I should tell to whom this certificate belongs to. Now, as I told, this certificate is going to become the asset. Okay. This certificate is going to become the asset, or this is going to become the value. Okay. So now what I'll do, if Karpagam University is existing on the blockchain, they will also have a wallet address, right? The wallet address will track their activity and also it will tell how many assets they have, right? So now if Karpagam University is there, I will give their wallet address here. So once this certificate is created, automatically it will be transferred to the wallet of Karpagam University or to any individual. Okay. So now leave out the other two fields. Okay. So now when I click issue certificate, what will happen? It will, this is the form, right? So the name, the designation, the institution, certificate ID, all these things are got. So now when I click this button, which function is getting called? Issue cert, right? Of course, this you should know HTML. When I click this submit button, I'm calling a function called issue cert. So let us go to that function. So this is that function, issue cert. Okay, now what I'm doing, I'm getting the values entered by the user in the form into these variables. Now the value I entered will be in this variable name. The designation I entered will be in this particular designation variable, int, CID, address, token, everything. Now, what should I do? I should create a variable, right? So my contracts dot methods dot issue certificate, and I pass all these variables to them. And the smart contract will receive all these values and it will assign it to the corresponding state variables, and it will give me a transaction ID. So now I'm going to click issue certificate, and you know, whenever we are storing, we have to pay a transaction fee. So now I clicked this. Can you see automatically my MetaMask wallet is opening, and it is telling that you are trying to make a transaction for which this is going to be the transaction fee. So whenever I do a transaction to the real blockchain, my wallet will tell you are trying to do a transaction and you are going to pay this much fee. So now I'm going to click confirm. So now what will happen? This transaction is now submitted onto Ethereum blockchain. This will be running, right? And you can even speed up the transaction. If you are ready to pay more ethers, you can pay. Like for example, if I pay 0.186 ether, it will take 12 minutes for this transaction to get confirmed. If I pay 0.222 ether, it will take 1 minute for me to complete. If I pay 2.73, it will only take 30 seconds for this transaction to complete. So if I want, I can speed up my transaction as well. And once you submit the transaction, automatically you can get the transaction ID irrespective of whether the transaction is succeeded or failed, which is similar to our day-to-day transaction. Whenever you do a transaction in any mobile application, you get the transaction ID, whether it is success or failure. So now this transaction ID, now if I go below and if I try to search this particular detail, and you see I am not getting any detail because this detail is still not stored onto the blockchain. It is still not stored. It is still pending only. It is still not stored. That is why when I searched view certificate details and I gave the certificate ID, it is showing all empty details. So you have to wait until this transaction is completed. And sometimes this transaction will take few seconds depending upon how maybe good is your internet connection or how good is the Ethereum that service is running properly. So it depends on how long it takes. So normally it should be completed in few seconds. So now you see a pop-up telling that transaction is confirmed, right? Can you see here? Transaction is confirmed, and here also you see the transaction that got completed. Now, if I click this, I will be able to see the transaction because now it is stored into the blockchain. So let us try. Can you see now? Karpagam College of Engineering, Department of CSE, Karpagam College of Engineering, Coimbatore, certificate ID, holder wallet address. And now you see here, total certificate is 11, right? If I refresh this page, it will become 12 because the Karpagam University certificate will also be counted. So let us refresh this. Can you see now? From 11, it has become 12. So That's all. This is how you write. It's if you look at it in a very simplistic point of view, you can easily understand. But it is not as simple as what it sounds. Okay. At least during the initial stage, if you follow this approach, no, you will not have any big problem in understanding. Take a small code like this, slowly add a few variables, add a few functions, and make it a big code until you become very familiar with the solidity. Similarly, you take this same code itself. Okay. There are only two things that you should change. One is this ABI. After this equal to, delete the existing ABI and copy whatever ABI you get after compiling. And for smart contract address, delete this smart contract address and paste your smart contract address. And functions also, you need not even change this line because the ABI and the contract address you would have changed. Here, mycontracts.methods. Give the function name that you want to call. I want to call view certificate. So I'm calling view certificate. You know, while creating the contract, you know what parameter it takes. Right? So you pass those parameters from here. That's all. If you do that, and if you know how to write JavaScript programming, these are the 3 lines that you should change. The ABI variable, the smart contract variable, and this particular function name that you want to call in the smart contract. If you do that, whenever this particular statement is getting executed, it will contact MetaMask, and if it is a storing transaction, it will open that pop-up asking you to confirm the payment. Once that is done, it is stored into the blockchain. And whenever you call view certificate, it will contact and get you the details. Remaining things are out of scope because I cannot teach HTML, I cannot teach JavaScript. You should know what is this if, ERR, console.log and all. You should know. Or you should know how a JavaScript works. Okay, so this is one thing. The other important thing that you should also know is there is a difference between send and a call. Can you see here? I'm calling a function issue certificate where I'm using send. But whenever I'm calling a view certificate, I'm using call. Send means it will send the transaction to all the nodes for validation and it will create a transaction ID. Because you are storing, right? It has to go through the consensus. So you have to call send, which will create a transaction ID. All people will do consensus and agree on it. How about call? Call will not create any transaction ID. And call is not going to call all computers. It is going to call any one computer from the blockchain and it is going to fetch the details and display it to you. So call is very simple. It is going to retrieve a value from any one computer. And that work is done by your browser. Your browser is going to give the request and it is going to contact one computer and fetch the detail. So there is no cost for retrieving the detail. So there is no transaction ID that is generated because it is the work that is done by your browser just by contacting one node in the blockchain. But whereas when you store, it has to go through the consensus process. There is some storage that is happening and you need a transaction ID for that. So you have to use send. That's all. If this is known to you, you can slowly start writing an application and you will be able to slowly increase and create as big application as you want. Even this application, what it looks very small, right? This has so many other concepts that is put into that. There are concepts like non-fungible tokens I have used. That is why I'm using the keyword called token ID. Okay. So now this is how you connect it. So now once you create your application, you go to inject Web3, click deploy, you will get the smart contract address. Then go create your front end and replace those variables I told. You will be able to create a application, right? I think this is what I could teach in 1 hour 15 minutes, because I know Web3.js is totally new for you people. Even if you are very familiar with JavaScript, Web3.js is still new. And in case if you are not aware of JavaScript, or if you have learned JavaScript before many years back, it would be difficult, but it is not that difficult. If you follow in the way I told, it is very easy. Secondly, I didn't show any other applications, because even if I give this application to you, if you do not have MetaMask installed, then it will not work. Then you might think, okay, this application is not working. It is not the case. Like, for example, you can quickly try. I'm just going to share this application link. All of you can try issuing a certificate. It will not work, because there is no MetaMask in your computer. But that doesn't mean that this application is not working. So any blockchain application that is existing as on today requires a lot of configuration, tools, settings that is to be done in your computer and browser, which is making people understand how an application even works. To be very frank, I was learning blockchain for 2 years. Okay. Until the 2 years, I have never seen any application. I have never seen any demo. No one has shown me any demo. I myself implemented, only then I myself was able to see the demo. Because it requires a lot of, there could be some demo. For example, yesterday we have seen that blockchain or a simulation kind of thing, right? That is only to help you understand how blocks are connected. If one block value is changed, it will affect all other blocks that is coming next to it. That's all. It is not doing any proof of work. When you click that mine button, there is no proof of work that is done. That's Shuma. It is only calculating the hash value. So using that simulation, you can understand, okay, this is how hash value is calculated. If I change it, it will affect all other things. That's all. It will give you that understanding. You have to remember that. Then you have to go to some other simulation, which will give you some other understanding. You have to remember that. Then you have to correlate all other things. Then you should understand, okay, this is how these two things are related. So this is one thing that is making people visualize blockchain more difficult. So at least during the initial stage, what I would request is, don't think so complex. Even you might be a super big domain expert in those areas. Forget everything. Even if you are good at HTML, JavaScript, even if you are a super web developer, forget all those things. For now, when you are learning blockchain, only these 3 variables you change. Understand how the communication is working. Then you can bring all your web technology into this. Similarly, to do with Ethereum also. So this simplistic approach at the initial stage will help you to have a good understanding of how actually the communication is working. Okay. Now I can show you something quickly. Okay. Now you guys have created this application, right? I'm going to deploy this roll number application into the blockchain. Okay. So when you click it, deploy the application also, you will get the pop-up like this, because you are deploying it in the blockchain. Okay. I can speed up the transaction. Yeah, the transaction got confirmed. Okay. And now, can you see here? Here it is showing blockchain. Can you see now? Because I now deployed this code, the sample code, what we wrote during the session, into injected Web3, which is the actual blockchain. Actual blockchain, what I mean is the real blockchain to a test network. Okay. Now, there are services that are already available. You need not worry about what Web3 is. Okay. There is this plugin. Okay. I think this is not the plugin. Here, this is the plugin. Here, there is a service. Okay, I forgot the name of the service. Let me see. Yeah, this one-click dApp. Okay. This is one service that is available. So now what you have to do here is, this is an application. Okay. Now you just need to copy your smart contract code, go to this one-click dApp. One minute. Can you see here? The storage example, what I wrote already automatically came in. Now I have to just paste the address. It's not getting copied. Sorry, 1 minute. Don't know why it is not getting copied. Okay, I think now it is copied. Okay, so now you see, I just activated that plugin which is called one-click DApp. Okay, and as soon as I click that, it automatically showed the compiled program. Okay, now I just pasted the smart contract address which I got after deploying. Now click generate DApp. Can you see? Now I click this. You already have a predefined UI. You need not sit and worry about what is this Web3.js here. I don't know what is this JavaScript and all. You need not worry about anything. You go here automatically. You have a simple UI that you can use to test this application, and you can also share with your friends or your colleagues or your seniors to test this application. Okay, I'm just clicking this link once again because some issue. Now can you see here get variable? Can you see here the same thing here? Name. I can give the same thing. Okay, and to read the variables, now you see return variable. I give check, it will show my name because I have previously I would have used, right, my network. Why it is not showing? Please switch to network. Please switch network to unknown. Okay, 1 minute. So there is some problem here. I don't know which. Okay, there is some issue which this is something new. So if you can use this now, once you deploy, instead of copying the ABI and the smart contract address and creating your own UI for sharing it with your friends or colleagues for testing, you can just activate this new one-click DApp. Okay, and you can give any name and the deployed contract address and click generate DApp. It will quickly give a small UI with a link like this. Okay, so you will be able to access this. This will be available for quite some time. Okay. So you can see here also. So this is one application I see created long back. So now this is the same application, the same roll number, same name, Mark 1, Mark 2. If I click display name and I click check, it will show the details. So this is one way. Now there are a lot of applications that is coming. You need not worry about what is the front end doing. Like, there are so many applications that have came up like this. You just need to know how to create a smart contract by understanding how this logic works. That's all. Now, if you use services like this, no, you will not know what is the importance of a smart contract address. You will not know the importance of a ABI. You will know it only when you actually write it by yourself. So for that, use this simplicity code. Try to use this code, understand the importance of ABI and the smart contract address, how you actually do all these things. Then maybe at a later point of time, if you switch to such applications, it will reduce your time. But using these applications will not give you any understanding of how a DApp works. So this is convenient, but not recommended if you are keenly interested in learning about blockchain. Okay. So yeah, and finally there is something called as Ethereum Explorer, which is nothing but a place where you can see all these transactions. like just like Blockchain Explorer, what we saw yesterday. Even if you click this deployment, no, if you click this, you will go to Ethereum Explorer, which will show, right? This is the transaction. This is part of this particular block. This got created before 6 minutes. And this is from the wallet address C6F, which is my wallet address. And it created a new contract. So this is the contract address. And this was only a contract creation. I did not transfer any 10 Ether from my account to someone's account. It was a contract creation. So there was no value I transferred, but there was a transaction fee. Okay. And if you want to see the transaction details, you will be able to see here and there some values, but not anything that is useful to you. Okay. And if you click this transaction, you will be able to see how many transactions has happened for this particular contract. Okay. So this is a Ethereum Explorer. Okay. So you will need to use all these things which are already available. The only thing is that you should know why it is used and where it is used. If you have a very basic, clear idea on this, then there are a lot of high-end simplicity tools like this, which you can use it to fast up your work. But at least during your initial stage, I would recommend you to sit and know all those details. And most of these things, I have written many examples, and all these things are available as a tutorial here. You can just need to, everything is very simple. I would have written only, if it is address, only that 2 or 3 lines. Every code will be not more than 10-15 lines. So it will be written very simplistic way. So yeah, that's it I have for this hands-on session. And thank you so much for patiently listening me for the last 2 days for 4 or 5 hours and letting me share my insights and knowledge on that. And if you are interested to learn more about this, currently we are running a series on the blockchain terminologies. Whatever I have learned, I'm trying to put it in very simple words. So this is our page. Okay. If you are interested, you can go here. So we are running a series like this. You will be able to learn the terminologies. What is hyperledger? H for hyperledger. H for hash rate. What is an hash rate? Okay. And so similarly, you will be able to see other things. G for gas. So if you look at these things, we are trying to put it with simple example, a simple diagram, a simple 2 or 3 words to understand that particular terminology of blockchain. And there are so many terminologies that you should know, which is not possible for you to learn in 2 or 3 days. So I would request you, if you are interested, you can follow our Instagram page or this LinkedIn page to follow our blockchain terminologies. And I've added the resources which I shared yesterday also. You can use. And thank you so much. Thank you for the opportunity. Any questions you can ask. And you can connect to me in LinkedIn to my name, Ramaguru Radhakrishanan. Any doubts, anytime you can contact me. I'll be happy to help. And remember, you will not be able to learn it as easy as possible. The learning can be simplified, but it will take a lot of time, at least 2 to 3 months of solid investment. If you put only, then you will be able to at least have a rough idea of how things work in blockchain or cryptocurrency. If that is not there, how many other webinars or programs we attend, it will be very difficult. Not to be harsh, but this is what I have personally heard from a lot of people and from my own experience. Thank you.
And participants, if there is any question?
Sir, thank you, sir. I have one doubt in MetaMask. I have an account, but I have 0 Ether balance. But in my test network, I can access some accounts. But in RO, your ROPST and test network, that it is not connecting and giving me the Ethers.
Okay, maybe I'll give you a different. You can. I'll share my number. You can also take down.
Okay.
So yeah, I've shared my number. This is my number. So if there are any doubts, please you can contact me. Today I'm out of town, so maybe from next Monday, I think if you can contact me once after going through, once this FDP is over, once you spend some time in reading the presentation, then maybe you can consolidate all your doubts, and if you can contact me or call me, anything is fine. I will be very happy to share the response or give you more information.
Okay, okay, sir.
And any participants, any queries?
No, sir.
Okay.
Thank you, sir.
Okay. Then let us wind up this session today. On behalf of Computer Science and Engineering Department, I would like to thank Ramaguru Radhakrishanan for sparing the 2 days of valuable content. The faculty who participated for these 5 days of inactivity program. And thank you, Ramaguru. And thank you, participants. And tomorrow the session
Thank you,
will
sir.
be at 9:30 a.m. And please try to join by tomorrow's session by 9:30 a.m. And tomorrow we have 2 sessions. The first session it will be between 9:30 to 11:30, and afternoon it will be 2 to 3:30. So there won't be a middle session. That is, there won't be a second session. Thank you, participants.
Thank you. Thank you, everyone. Thank you. Have a nice time. Bye.
Thank you, sir.